Hi friends, welcome back. In the last videos we covered what is a lambda expression, how to write lambda expressions, what is functional interface, how you can use a functional interface to invoke lambda expressions. Everything is clear. Next 2 or 3 examples I covered how you can use a lambda expressions concept for multi-threading. Have you remembered, right? Okay. So now in this session we are going to talk about how you can use lambda expressions concept for collections, because in our Java collections is a very important concept, right? If you use lambda expressions for collections, then you can able to see, because it's a very common day-to-day programming requirement, right? So now can you, I hope you people may aware collections concept or may not aware some people. That's why just a few minutes basic idea I will provide what is collections, and then how you can apply lambda expressions concept for collections. Clear, right? Sir, can you please tell what is collection? Yes, man. What is collection? Anyone? What is the collection? Normal day-to-day life word. Sir, collection of books are there. Collection of markers are there. Collection of pens are there. Like what is a collection? Collection of beer bottles are there. Are you getting? Collection means what? A group of items by default considered as collection. Normal day-to-day terminology, right? Even programming terminology also same terminology only. What is collection, sir? A group of objects. We can use the word in Java. Yes, Java is object-oriented programming language. In Java, collection is nothing but what? A group of objects represented as a single entity. Remember this. Suppose I have, sir, it is a collection. It is a collection. This collection internally contain objects. Remember this one. Sir, first object, second object, third object, like, sir, this group of objects represented as a single entity. Can I use the word? Is it a collection or not? Yes, itself is collection. I hope it's very clear, sir, when we should go for collection. If you want to represent a group of objects as a single entity, then we should go for collection framework. Okay, like, sir, now in collections there are multiple concepts are there. Sometimes you may heard about list concept. Regarding sometimes you may heard about list concept. Sometimes we may heard about set concept. Regarding set concept. Sometimes we may heard about list concept, set concept, and then map concept. Map concept, like. So do you know these things are interfaces. Interfaces, right? Now the corresponding implementation classes also there. Okay, don't worry about that. So sometimes we should go for list collection, sometimes we should go for set collection, sometimes we can go for map. Not only this, even queue concept also there in the 1.5 version. That is not our requirement, because I'm not going to discuss collections concept in detail. Just a basic idea. The people who don't know about collections, for them I'm talking about this, right? Okay, sir, what is collection? Up to this is the very clear, right? Can you spell out what is the collection? A group of objects as a single entity itself is considered as collection. Next, what are various types of collections? List concept, set concept, map concept, like. Now, sir, when we should go for list? What is the meaning of list concept? Now observe very carefully, sir. Sometimes what will happen is I want to represent a group of objects as a single entity where insertion order preserved. Are you getting that? What is this one, sir? Where insertion order must be preserved. In which order we inserted, in the same order only inside memory the data should be saved. Regarding insertion order must be preserved, and duplicate objects are allowed. Remember that insertion order must be preserved and duplicate objects are allowed. If you have this type of requirement, then happily we can go for list concept, right? Regarding what is collection? In that collection, list is one type of collection. When we should go for list concept is, if you want the insertion orders or in which order I added objects, in the same order only the data should be saved. Next and after that, duplicate objects are allowed. Duplicates must be allowed, sir. If you have this type of requirements, then happily we can go for list concept, right? Sir, theoretically okay. We are not sir seeing much clarity. Can you please explain with a small code? Can you please explain with a small program so that we can able to understand much clearly, like you people may ask. Very simple, sir. Observe that a small coding example I want to talk, sir. Do you know, I told already, list itself is an interface. What are various implementation classes are there? You can go for array list. You can go for array list. We can go for linked list. We can go for linked list. And we can go for vector, or for the vector child class is there stack. Do you know all these things are implementation classes of list? Based on our requirement, we can go for either array list or linked list or vector or stack. But anyway, it's not correct time to talk about all these things. That is collections concept. There you require to talk in detail, right? Sir, just observe. My requirement is, let me take array list, sir. I want to create array list object. Are you getting? Array list of string L is equal to, array list of string L is equal to new array list of string, sir. Array list of string L is equal to new array list of string. I'm taking, right? Now L dot add of just I want to insert Sunny. Are you getting? Sir, in the first line, what I'm doing? What I'm doing in the first line? Just I'm creating an empty array list object that can hold which type of objects, right? String type of objects. Are you getting? This is the generic concept. Array list that can hold which type of objects, right? String type of objects, right? Sir, L dot add of Sunny. Next, L dot add of Bunny. Are you getting? L dot add of Bunny like this. L dot add of Chinny, I'm taking, sir. L dot add of Chinny like. Next, L dot add of Sunny, like this I'm taking. Now observe. Can you please tell how many objects we added? 4 string objects we added. What is the first one? Sunny, Bunny, Chinny. Next, and after that Sunny. 4 objects we added, right? Now system dot out dot println of L. If you consider, regarding SOP of L, if you consider, what is the output by default we are going to get, sir? What is the first object? What is the first inserted object? Sunny. Are you getting? Now Sunny. Next, what is the second inserted object? Bunny. Are you getting? What is the second inserted object? Bunny. Okay, like. What is the third inserted object? Chinny. Next, fourth inserted object is the Sunny again. Are you getting? So if we print this array list, this is the output by default you are going to get, sir. Very clear. Insertion order preserved or not? Yes, insertion order preserved. In which order we added, in the same order only inside memory the objects got saved. Point number 1. If it is the list, insertion order preserved. Second one, sir. Have you observed? Sunny, here I added, here also I added. How many times I added, sir, Sunny? 2 times. 2 times I added. In the output, either Sunny is coming 2 times or not? Yes, 2 times, right? Okay. Sunny is going to come 2 times because list allowed duplicates. Remember, list allowed what? Duplicate objects, right? Is it clear for all of you, right? Sir, what is collection? What is a list? When we should go for list concept? If you want the insertion order, if you want to duplicates, then we should go for list concept. Okay. Let me execute this code, sir, so that you people can feel more comfortable, right? Observe that carefully. Have a look once. Sir, this is import java.util.arraylist class test I'm taking, main method I'm taking, sir. Sir, here I created array list object. Array list of string L is equal to array list of string L dot add of Sunny, Bunny, Chinny, Sunny, same SOP of L. Okay, let me execute this code. If I consider that Java C tester.java, let me compile. Happily the code is going to be compiled, no problem at all. Are you getting that? Let me compile. Happily the code is going to be compiled, no problem. Let me execute this code. Yes. Observe what is the output by default you are going to get, sir. Sunny, Bunny, Chinny, Sunny, like this. Sir, in which order we added? In the same order only data is going to come. Next, Sunny, even you added 2 times, both the times covered. Is nothing but here Sunny, here also Sunny by default. Everyone can able to understand, right? Now it's very clear for you people, right? Sir, what is collection? What is the list concept? If you want insertion order, if you want to duplicate objects, then we should go for list concept. Clear, right? Sir, up to this it is very clear what is list. Now let me talk about what is a set concept, right? So do you know, in the case of list, duplicates are allowed or not allowed? Can you please tell? Duplicates are allowed. Insertion order must be preserved or not? Yes, insertion order preserved in the case of list, sir. But now in the case of set, sometimes my requirement is, observe, sir, I don't want to duplicates. Hey, duplicates are not allowed. I don't want to worry about order. In any order you can save. No problem. Insertion order not required to preserve. But duplicate objects I don't want. If you have such type of requirement, happily we can go for set concept, right? Remember this one? Sir, I want to send SMS message for all my students. Okay, in which order you want to send? Don't worry about the order, but duplicate numbers are not allowed. Are you getting? So if you don't want to duplicate, if you don't want to worry about order, then we should go for what? Set concept. Clear for all of it when we should go for set concept, right? Okay, if you don't want to duplicate, if you don't want to worry about order, then we should go for set. Let me go for a small example, then you people can able to understand, right? Okay, so now for this set, what are various implementation classes are there? Sometimes we may have hash set. Sometimes we may have tree set. Sometimes we may have tree set. Like there are multiple. Here, sir, the objects will be stored based on hash code. We don't know order. If you want a sorting for the set, all elements can you please insert according to some sorting order? Then we should go for sorted set. I mean tree set. We will discuss in detail. First, anyway, just aware. Let me go for a small demo related to the hash set. Observe. I'm creating hash set object. I'm creating a set object. Which type of elements you want to hold? String type. Hash set of string. H is equal to new hash set. New hash set of string set. Are you getting? Hash set of H is equal to hash set of string H is equal to new hash set of string. Okay, well, hash set of string. Now H dot yard of Sunny. I'm taking H dot yard of Sunny. H dot yard of Bunny. H dot yard of Bunny. I'm taking Sir Sunny Bunny. H dot yard of Chinny. I'm taking. Next H dot yard of Sunny. Like this I'm taking, sir. Have you observed? First one Sunny I added. Bunny, Chinny, Sunny. Like this I added, right? Now let me print system.out.println of H, sir. Can you please guide? If it is the list object, how the data, what is the output you are going to get? Sunny, Bunny, Chinny, Sunny. But this one is set. Never worry about order. So in which order the output we are going to get? Sorry, we don't know that. Next, duplicates are allowed or not allowed? Duplicates are not allowed. Even we are taking Sunny 2 times, but Sunny is going to come only once. Remember this. That's why the output is Sunny. The output is Sunny. next and after that bunny, next and after that chinni. By default we are going to get, sir, sunny we will get only once, it never going to get two times. But in which order these objects are going to come, sorry, I can't give the guarantee, because this one is nothing but set concept, right? Clear? Let me execute this code. Have a look once. Have a look once. Observe that. Import java.util.hasset. Next class test hasset of string L is equal to new hasset of string L.add of sunny, bunny, chinny, sunny, sop of L. Okay, like this, right? I am taking it is the hasset object, right? Hash set of string, sir. Have a look once. Observe the output, sir. Here, let me compile. Happily the code compiles fine. What is the output? By default you are going to get, sir, chinny, bunny, sunny. Sir, can you please observe how many times sunny is coming? Only once. Even though we added two times, but it's going to come only once, right? Sir, here I added once, here I added once, here also I added once. Sir, total two times I added, but the output is always going to come only once, sir, because duplicates are not allowed. Next, in which order we added, have you observed? First I added sunny, next bunny, next chinny, but output if you observe, sir, chinny, bunny, sunny, sir, different order by default is going to come. That's why, sir, in set duplicates are not allowed and insertion order not preserved. Sir, if you don't want duplicates, if you don't want worry about order, then happily we can go for set concept, right? Clear? Up to this, how many collections we covered, sir? List concept, set concept. List and set, what is the difference? The very, very important question for the interview room. Minimum crores of times this question was asked, sir. What is the difference between list and set? Main difference, list duplicates are allowed, set duplicates are not allowed. List insertion order preserved, but set insertion order not preserved. Clear up to this? Sir, up to this, it is very clear what is list and set. Now, the last collections, sir, where you have to get the basic idea is map concept. Remember that. Sir, up to list and set, whatever we covered, this list and set always talks about to hold a group of individual objects. Sir, first object, second object, third object, like this, right? There is no relation between these objects. Sir, sunny, bunny, both are different, no link at all. Bunny, chinny, both are different, there is no link at all. Okay, but sometimes my requirement is I want to represent a group of objects as key value pairs. Are you getting? I want to represent a group of objects as key value pairs. If you want to represent a group of objects as key value pairs, then we should go for map concept. Are you getting? Then we should go for map concept, right? Very, very important question for the interview room. What is the difference between list and a map, or set and a map, or collection and a map? Sir, collection usually talks about a group of individual objects. But if you want to represent a group of objects as key value pairs, then we should go for map concept. Best example, sir, observe roll number, next and after that name. Roll number, name of the student. Similarly, sir, mobile number and address. Mobile number and address. Are you getting? Mobile number and address, like these things are by default considered a map. If you want to represent a group of objects as key value pairs, then we can go for map concept. Clear, right? Sir, let me show a small example so that you people can feel more comfortable, right? Sir, here let me take, there are for the map multiple implementations are there. Hash map is one implementation, tree map is another implementation, like that. Sir, what is hash map? How you can able to create hash map object? Observe that hash map key is a string type and the value is a string type. Remember that hash map, sir, string comma string. What is the first one, sir? It is the key. Second one, sir, it is the value. Now new hash map of new hash map of string comma string. I got a new hash map of string comma string. I create a hash map object. Remember, sir, now I want to add the key values. If you want to add key values, then we require to call which method, sir? Put is the method we have to call. Okay, now a for apple I'm taking. Observe that a for apple. A is the key and apple is the value. Remember that key value like. Sir, similarly, m dot put of z for zebra I'm taking. Z for zebra I'm taking, sir. M dot put of d for or otherwise I'm taking Durga. Yeah, the key and Java, yeah, the value. Regarding Durga and then Java itself has the value. Now m dot put of, have you observed? A for apple, Z for zebra, Durga for Java. Next and after that, B for boy or banana, like you can take anything. P for boy. Next, m dot put of T for tiger, like this I'm taking, sir. Have you observed? Sir, I created one empty hash map object. For this hash map, I added first key value, second key value, third key value, fourth and fifth. So total how many key values I added? 5 key values by default I added, right? Now let me print SOP of M. Remember that SOP of M. Observe, it is the hash map. Sir, duplicate keys are not allowed. In any map, key should be unique. Duplicate keys are not allowed. Order not preserved. Hashing right, order never preserved. Hashing related data structure not preserved. That's why what is the output by default we are going to get, we can't expect. Okay, so now let me consider within curly braces A is equal to apple. Next and after that, Z is equal to zebra. Durga is equal to Java. Next, B is equal to boy. Next, T is equal to tiger. This style output is going to come. Only variation is order wise, no guarantee at all. Are you getting right? Sir, just basic idea. When we should go for map concept. If you want to represent a group of objects as key value pairs, then we should go for map concept, right? Are you able to understand? Just my intention is just to create some basic idea about these collections. What is the list? What is the set? And then what is the map? Let me execute this code, sir. Observe that. Have a look once. Import java.util.map hash map class test. Here I created a hash map object. Sir, key string type, value is also string type, right? Sir, A for apple, B for zebra, Durga for Java, B for boy, T for tiger, SOP of M. Are you getting SOP of M like this, right? Sir, now let me execute this code. What is the output? By default we are going to get, sir. Happily the code is going to be compiled. What is the output by default we are going to get, sir? Have you observed? A for apple, B for boy, T for tiger, Z for zebra, Durga is nothing but Java. Like this we are going to get. Sir, can you please tell, is there any guarantee for the order? No. Sir, after A, Z I took. Have you observed? After A, Z I took, sir. But in the output, if you observe, what is the output by default you are going to get, sir? Can you please have a look once? Sir, A for apple. Okay. Second B for boy is coming. But actually here, second I added Z for zebra. But anyway, we are not going to worry about order. If you want to represent a group of objects as key value pair, then we should go for which concepts are? Map concept. Clear? Everyone got the basic idea. The people who don't know about collections also, this knowledge is more enough to understand how to apply lambda expressions for our collections. That is our next terminology. Sir, let me summarize. What is collection? Any group of objects as a single entity is called collection. Sir, when we should go for list? Sir, insertion order must be required. Duplicate objects are allowed. Then we should go for list concept. When we should go for set concept? Sir, I don't want duplicates. I don't want to worry about duplicates, right? Sir, I don't want duplicates. I don't want to worry about order. If you don't want insertion order, if you don't want duplicate objects, then we should go for set concept. Next, when we should go for map concepts, if you want to represent a group of objects as key value pairs, then we should go for what? Map concept. That's all. The people who don't know about collections also, basic idea I hope everyone got. List, set, and then map concept. Of course, one more concept is there, queue concept. There we will discuss somewhere. Maybe if you are going to explore collections concept, there you will worry. But here my concentration, how to apply lambda expressions for collections. You should have basic idea about collections concept. Clear, right? That's all. Sir, in the last videos we covered very clearly what is collection, what is list, what is set, and what is the map concept. Clear, right? Sir, now I want to introduce one more character, very important, where we can use lambda expressions for collections. What is that important character is comparator. Remember this one. What is this? Comparator interface, right? Sir, very, very important. If wherever comparator is there, happily our hand should go for lambda expressions concept. Because the reason is, comparator interface contain only one method, only one abstract method. What is that abstract method? Is compare method. What is that abstract method, sir? Compare. Compare is the method. Okay. Comparator interface contain only one abstract method. What is that abstract method, sir? Compare. Compare is the method, right? Okay. So if any interface contains single abstract method, SAM, single abstract method, Samantha method, sir. Okay. Single abstract method is by default considered as functional interface. Wherever functional interface concept is there, happily we can apply lambda expressions concept. Have you remembered? In our first session, we covered in detail what is the lambda expression, functional interface, and so on. Wherever functional interface concept is there, happily we can apply lambda expression, no problem at all. Okay, now, sir, comparator contain compare method. When this compare method is going to be required, sir, what is the use of this comparator concept? Simple, sir. Comparator concept to define our own sorting. To define our own sorting. Sorting is nothing but customized sorting. Customized sorting. If you want to define our own sorting, sir, then we should go for comparator concept. Okay, like, sir, this comparator contain how many methods, right? How many methods? Only one method. What is that method? Only one abstract method. What is that method? Compare. Sir, this prototype, this behavior, compulsory you people should aware. Minimum in the next 5 to 6 videos, this comparator compare, I'm going to use repeatedly. That's why you people should have clear clarity, sir. Just observe that. Just observe. What is the complete prototype, sir? Public int. What is this one, sir? Public int compare. Public int compare. Can you please compare? How many objects we require to compare, sir? 2 objects. Object obj1, comma, object obj2, sir. So, if you are talking about sorting, whenever 2 objects came, sir, in which order I have to place these 2 objects? Sir, how the JVM is going to decide? By using this compare method. Sir, while defining sorting, sir, to place our objects in sorting order, my JVM is always going to use comparator compare method, right? Suppose first I provided 10, second I provided 20, sir. Assume that. Sir, now this 20 has to come after 10 or before 10, sir, like, or both are equal. How? Being human being, sir, 20 should come after 10. If you are talking about ascending order, 20 should come after 10. You know that. But my requirement is, sorry, sir, my JVM is not a human being. How the JVM can decide 20 should come after 10? Internally, wherever sorting is required, JVM is always going to call which methods are compare method, right? Compare of 10 comma 20. Observe that, compare of 10 comma 20. Sir, what is the first one? OBJ1. Second one? OBJ2, sir. Very simple. If OBJ1 has to come before OBJ2, observe very carefully. If OBJ1 has to come before OBJ2 according to our required sorting, okay, then this compare method is going to return -1. Remember this, very very important, sir. Return -1, return negative, need not be -1, -100, -1000, any negative value, returns a negative value if and only if OBJ1 has to come, sir, before OBJ2. Are you getting? OBJ1 has to come before OBJ2. Sir, if you want to arrange a sorting order, sir, OBJ1 has to come before OBJ2. If it is the case, compare method is going to return -1. Sir, JVM is always going to call compare method. If the compare method returns -1 means it is always going to place this OBJ1 before OBJ2. So, how the JVM will decide sorting order internally? It is going to call comparator compare method. Clear, right? Sir, for the list case, for the set case, for the map case, wherever to define our own sorting order internally, we require to use which concepts are comparator. JVM is always going to call comparator compare method. But in collection framework, while discussing your Java classes, you have to explore much. But my concentration is always with respect to Lambda expressions only I'm talking. Make sure you should aware that point, right? Now, sir, return negative value. Return negative value. It may be -1, -100, anything. If OBJ1 has to come before OBJ2. Now, return positive value. Return positive value if and only if OBJ1 has to come after OBJ2. Observe that very carefully, sir. If OBJ1 has to come after OBJ2, return positive value. Next, return 0. Return 0. If OBJ1 and OBJ2 are equal. Observe that, sir. If OBJ1 and OBJ2 are equal, then automatically return 0. Remember, sir, these words are very very important. First one I used comparator. Comparator interface contain how many abstract methods? Single abstract method. What is that single abstract method, sir? Sir, compare method. Compare method, right? Next, because it contains single abstract method, comparator is the functional interface. Next, comparator compare method, return type is int value. Return negative if and only if OBJ1 has to come before OBJ2. Return positive if and only if OBJ1 has to come after. Positive means after, negative means before. So return 0 if and only both are equal. Everyone can bear? Are you able to understand? Sir, because this concept is very important, please inject in your mind. Because the reason is, while defining our own sorting for list or set or map concept, everywhere we have to use this comparator compare method. That's why you should aware. Can you please tell? Comparator interface contain how many abstract methods? How many abstract method? Single abstract method. Are you getting that? What is that abstract method? Compare. So can I use the word comparator interface is the functional interface or not? Yes, because it contains single abstract method. That's why it is the functional interface only. What is the return type of compare method? Int value. A return type of compare method, int value. When it returns negative, if OBJ1 has to come before OBJ2, negative means before, positive means after, 0 means both are equal. Clear, right? Okay. So this who is going to use compare method? Internally, JVM is going to use compare method to decide sorting order while inserting your objects in our collection. But how you can able to use this concept, I will discuss. Clear, right? Comparator, compare. Positive value means after, negative value means before, 0 means equal. Clear? Sir, now it's very clear what is comparator and whether it is a functional interface or not, what it contains compare method. Now, for the array list, I want to define sorting for the array list by using comparator. Without lambda expression, with lambda expression, I will cover both so that you people can feel how to use lambda expressions concept for our collections. That's about my main target. For that, all these nonsense I covered, right? Okay, observe that very carefully, sir. I'm taking one array list object. Regarding what is this object, can you please read? Array list of integer L is equal to new array list of integer. Like this I'm taking, sir, array list of integer L. Now L dot add of 10, 0, 15, 5, 20. Can you please observe which elements I added? 10, 0, 15, 5, 20. Sir, have you remembered? In the case of array list never talks about sorting order. Regarding never talks about sorting order. List always talks about insertion order. It never talks about sorting order, right? That's why if you print before sorting, what is the output by default you are going to get, sir? Sir, just 10, 0, 15, 5 and then 20. This is the output, sir, because array list is always talks about what? Insertion order. Okay, sir, I want to define sorting for this array list. How you can able to do? Let me execute up to this. Whether insertion order preserved or sorting order preserved, I will explain. I will look once. Observe that. I want to execute this code, sir. Here class import java.util.array list. Array list of integer L is equal to new array list of integer 10, 0, 15, 5, 20. Like this I'm taking, sir. SOP of before sorting. Same. Just let me go for here. Observe that. Happily the code compiles fine. What the output by default you are going to get, sir? Before sorting, insertion order by default you are going to get, sir. Before sorting, what is the output by default you are going to get? If you observe that, insertion order by default got preserved. Okay. Now I want to apply sorting for the list. I want to define sorting for the list. List never talks about sorting. If you want a sorting for the list objects, then we should go for comparator concept. Already I covered, right? Comparator concept. Which method we have to use? Very simple. Very simple. Here collections. Collections is a class is there, sir. Collections dot sort we have to use. Collections dot sort. Hey, can you please sort? Sort. Which thing you want to sort? This L. L means list. List, sir. According to which comparator? By using which comparator you want? By using which comparator you want? Here you have to pass comparator object. Regarding comparator implemented class object you require to pass, right? But of course how to define that part I'm going to take care. So if you want to sort elements present inside a list, then collections dot sort is the method L of comparator object we require to pass. Remember this, comparator object we require to pass, right? So now if you are not passing comparator, I don't want to pass comparator. Observe that, I don't want to pass comparator, right? Sir, if you are not passing comparator, what will happen is all these elements will be sorted according to default natural sorting order. Remember this one, according to which sorting order, sir? Default natural sorting order. Default natural sorting order for the numbers is ascending order. Default natural sorting order for the numbers is ascending order. Remember this one, ascending order, right? Default natural sorting order for the string objects. Default natural sorting order for the string objects is alphabetical order. Do you know dictionary? Dictionary order, sir. Alphabetical order. Observe that carefully, right? So first point you should aware, sir, I want sorting. Sir, I want sorting. Then collections dot sort. By default, this sort method always talks about ascending order only for the numbers. Default natural sorting order, right? Sir, now let me print this one. System.out.println after sorting. After sorting, remember after sorting, L I'm taking. Do you know? I'm not using any comparator because internally this sort method is going to take care about default natural sorting order. Okay, let me execute up to this. Observe carefully, sir. Observe a bit very carefully. Can you please guide what is the method I require to use? Collections dot sort of L. Collections dot sort of L. Next, system.out.println after sorting. Are you getting? System.out.println after sorting. After sorting, L I'm taking, sir. Sir, but anyway, here I'm using collections concept. Let me take import statement about collections also. Okay, that's all. Now, observe, sir, before sort method, default natural sorting order, after sort method, before sort method, insertion order, after sort method, what is the output we are going to get, sir? Can you please observe? Happily the code compiles fine, no problem at all. What is the answer by default we are going to get, sir? 0, 5, 10, 15, 20 like this, right? 0, 5, 10, 15, 20. Happily we are going to get. Sir, this is default natural sorting order. But now my requirement is, sir, I don't want this bloody default natural sorting order. I want my own customized sorting order, sir. I want a descending order. If you want your own sorting order, then we should go for comparator concept. Are you getting that? How to customize our own sorting, how to define our own sorting, our own customized sorting by using which concepts are? Comparator concept. Sir, now how you can apply comparator for this concept? I will explain. Just have a look once, sir. Up to this is very clear for you people, right? Sir, default natural sorting order, how you can apply for the list? By default, list always talks about insertion order. It never talks about sorting. If you want a sorting, then we require to call collections dot sort. Sir, collections dot sort, default natural sorting. I want customized sorting. Then comma comparator object we have to pass. Are you getting? Comparator object we have to pass. Sir, you require to write a class that implements comparator. That implemented class object you have to pass. Okay, let me write, sir. Here class my comparator. Observe very carefully. Class my comparator implements class my comparator implements comparator. Sir, here which type of objects we are adding? Can you please guide? Integer type. That's why which type of comparator you want to implement? Integer type. Observe that very carefully, sir. I'm defining my own implementation class for the comparator, right? Next, we have to provide implementation for which method? Public int compare method. Public int compare method. Now here have you observed integer I1 comma integer I2. Integer I1 comma integer I2. Whenever we are passing this comparator object, sir, that comparator object means new my comparator, because that is the my comparator is the implementation class. If I am passing this class object while defining sorting, JVM is always going to call which method? Compare method, right? Sir, you required which is sorting? Hey, respond, man. You required which is sorting? Ascending order or descending order? If you want ascending order, already we define collections.sort. But I want a descending order, my own sorting order, descending order. What I have to take is, then we should go for comparator. Descending order means, can you please tell? Suppose 10 and 20 is there. In descending order, which one will come first? Respond, man. Which one will come first? 10 and 20. Descending order. Descending order means higher value first and then smaller value next. That's why here 20 first and then 10 is going to come. So make sure OBJ1 has to come after OBJ2 if OBJ1 is the smaller value. Because have you remembered, right? Sir, if you want before negative, if you want after positive, if both are equal, 0. Somewhere we covered while discussing comparator concept, right? Now here if you want OBJ1 after OBJ2, you require to return positive value. If you want OBJ1 before OBJ2, then you have to return -1. Sir, these two are equal. If these two are equal, assume equal, then you require to return 0. Sir, based on your provided return value, JVM is going to arrange sorting order. Clear, right? Okay. Now observe that if I1 greater than I2. Sir, observe carefully. If I1 greater than I2, sir, I1 is the first bigger value. I1 is the bigger value when compared with I2, sir. Bigger value should come before or after. Don't get confused. Which type of sorting we required? Descending order. In descending order, bigger value should come before only. So if I1 greater than I2 means, sir, OBJ1 means I1 should come before. That's why return -1. Any native value you have to return. -1 means what? Before. Next, else if sir, I1 is smaller than I2. Else if I1 is smaller than I2, what is the meaning of that? Sir, first object is the smaller, sir. In descending order, smaller object should come after. That's why return +1. Return +1, sir. Sir, else it is not greater, it is not smaller, then automatically else both are equal. If both are equal, we are not required to insert that element, no problem at all. Return 0 like this I'm taking. Are you getting? Return 0 like this I'm taking, sir. If you implement like this, okay, then sir, JVM always going to use compare method. So based on the return value, it is going to arrange. If you are going to return -1, then OBJ1 value should be come before. If you are going to return +1, then OBJ1 value should come after OBJ2. Next, if you are going to return 0, then that element by default won't be inserted. Okay, but anyway, just directly I am coming to this concept, but better to explore collections concept to get much clarity. Just my intention, how to use lambda expressions for collections, just basics I'm introducing, right? That's all clear, right? Up to this, let me execute this code so that you people can feel comfortable. Observe, I'm taking collections dot sort of L comma new my comparator. While defining sorting for these elements internally, JVM is always going to call compare method. Assume that, sir, 10 comma 0. Which element is already inserted element? 10. Next, which element we are trying to insert? 0. Now JVM is always going to call 0 comma 10. Compare of 0 comma 10. 0 comma 10, 0 greater than 10? No. 0 less than 10? Satisfied. Satisfied means what it's going to return? Positive. +1, positive. Positive means 0 should be placed after 10. 0 should be placed after 10 means 10 followed by 0. Is it descending order or not? Yes. So internally, while saving your object, JVM is always going to call which methods are? Compare method. Remember, sir, make sure, sir, to get much clarity, you have to explore collections concept. Remember in detail. If you want much tracing and so on, better to go through collections concept, right? Even in YouTube, if you can type Durga sir collections, then automatically, sir, all these things I explained very clearly, neatly. There you can able to go through that, sir. Okay, let me execute this code. Now observe that the same example, sir, class my comparator implements comparator of integer compare method. If I1 greater than I2 means first object is greater than second object, sir, greater object should come before, that's why return -1. If a first object is smaller than second object, first object should come after, that's why return +1. If both are equal, return 0, sir. Okay, same thing, collections dot sort of L comma new my comparator. After sorting, what is the output we are going to get? Just observe a bit very carefully about this one. The code compiles fine. What is the output? By default we are going to get, sir, after sorting 20, 15, 10, 5, 0 like this. Correct or not? Sir, this is insertion order. This is my own sorting order. Which is sorting order I define, sir? This is nothing but descending order. Everyone can able to understand? Comparator concept, compare method concept applicable for customized sorting to define our own sorting, right? But now let me use a small shortcut for this. What I want to take here is, now listen this one. If I1 greater than I2, observe carefully, sir. If I1 greater than I2, what I have to return? -1. Else if I1 less than I2, return +1, else return 0. Now instead of writing this much code, I want to take a small shortcut. What I want to take? Return, sir, -1. When you have to return -1? If I1 greater than I2. That's why I1 greater than I2 question mark. Conditional operator. I1 greater than I2 question mark. What I have to return? -1. Okay, -1. That's all. If this condition satisfied, return -1. Okay, well, colon, else, sir, else means this condition, I1 less than I2. Else means I1 less than I2. Sir, if I1 less than I2, I2 question mark. If this condition satisfied, what I have to return? +1. Else, sir, return 0. Sir, this total thing we can able to replace a single line. That is the power of ternary operator. Sir, have you observed? If I1 greater than I2, sir, first object is greater than second object, sir. If the first object is greater than second object, in our descending order, first object should come, greater object should come before. That's why -1. If this condition is not satisfied means I1 less than I2, sir. Sir, if I1 less than I2, smaller object should come after. That's why positive. So if this condition also not satisfied, sir, means both are equal, then automatically return 0. How beautiful it is. Observe that, sir. Analyze a bit carefully with paper and a pen, then you can able to understand easily, right? Nothing. So this much if else, just I'm replacing with just this code, sir. Even in our next examples, I'm always going to use this shortcut only. Take a bit special care, sir. Observe carefully. Here, legend. Can you please guide, sir? I don't want to use this bloody code. Here, just directly return. Sir, if I1 return I1 greater than I2 question mark. Sir, if this condition is satisfied, what I have to return? -1. Else, sir, if this condition is satisfied, I1 less than I2, sir, question mark. If this condition is satisfied, return +1, else return 0. That's all. What is the need of using all this nonsense? Regarding just you can use directly only this line. Now execute this code. Am I going to get same output or not? Perfectly, sir. Same output by default you are going to get. Yes, have you observed? 20, 15, 10, 5, 0 like this perfectly it's going to come, sir. So by default array list never talks about sorting order. It's always going to talks about, sir, insertion order. if you want a default natural sorting order, then collections dot sort of L directly without comparator. Default natural sorting order always talks about ascending order for the numbers. I want my own customized sorting order like a descending order, then we should go for comparator concept. You require to write a comparator that implements comparator interface. What is the method we have to use? Compare method, like this, right? Any doubt up to this? Are you able to understand how to apply sorting? How you can apply sorting for the array list without lambda expressions, only with the comparator concept. If you feel comfortable, now I will remove this functional interface implementation. I will replace with lambda expressions. Now the power by default you people are going to get, sir. That part I will discuss. Up to this is the clear, right? Okay, that's all. Sir, up to this we covered how to apply, how to define sorting order for the list or for array list, right, by using comparator. But I didn't use lambda expressions concept. Now the time came to define customized sorting by using what? Lambda expressions. Sir, it's a very common word. Sir, how to apply lambda expressions for collections? Can you please give at least one example? Like this is a very common doubt from the students. Now, sir, I'm ready to use lambda expressions to for collections concept, right? Now observe that. Just I took a small array list L, array list of integer L is equal to new array list of integer. L dot add of 10, 0, 15, 5, 20 before sorting, right? Sir, have you remembered how you can define our own sorting? L comma new my comparator. Are you getting? L comma new my comparator. I have to write separate class my comparator, implements comparator. Next I have to implement which methods are? Compare method, like this. Sir, now comparator interface contain single abstract method compare, which is always functional interface, right? So wherever functional interface object is required, happily we can replace with lambda expressions. I covered already in the last session. Have you remembered, right? Okay, sir, now here why don't you replace this comparator object with a lambda expression? Is it possible or not? Observe that. Observe a bit very carefully, sir. Same example with the lambda expression I want to apply. Collections dot sort of L comma, it is always expecting comparator object. It's always expecting comparator object. Sir, now comparator contain compare method. We know comparator contain compare method, which can take two arguments. You know, right? Now L comma I1 comma I2. If I can take like this, lambda expressions are these things will become arguments to compare method. Automatically my compiler and JVM can able to identify that. Okay, I want which type of sorting, sir? Descending order. Descending order means bigger value should come before smaller value should come after. That's why, sir, if it is what I have to return statement is optional in lambda expressions. Remember here I1 greater than I2. If I1 greater than I2, bigger value, sir, I1 is the bigger, it has to come before. That's why -1 colon. Sir, if it is first object is greater than second object, then I have to return -1. If the first object, sir, not greater than I2 means else part, right? Now if I1 lesser than I2, if I1 less than I2 means first object is bigger, sir, first object is smaller object should come after in descending order. That's why +1 I'm taking. Sir, it is not greater, it is not smaller, then obviously what about its value? 0. Okay, like, sir, the total comparator object we can replace with this lambda expression. what is the need of separate? What is the need of separate implementation class? My comparator, implements comparator, all these are nonsense, not required. Are you getting? In our collections, wherever functional interface you are using, happily we can replace with the lambda expressions, right? Comparable concept, comparator concept, functional interfaces, all these. Wherever we are using functional interface, sir, whether it is the collection, whether it is the multi-threading, whether it is the exceptionaling, anywhere, sir, happily we are allowed to use lambda expression, right? Sir, how beautiful it is. We are not required to write separate my class, my comparator, implements comparator, public in compare, all this nonsense is not required. That's all. A simple lambda expression. My compiler can able to understand this one. JVM can able to understand. Clear for all of you, right? Just have a look once. I want to execute. Here, see this one. See this one. Earlier example, this is public class my comparator implements and so on, right? What I want to do, I don't want the comparator object directly. I want to replace with the lambda expression. I1 comma I2 I'm taking, sir. Do you know these are the arguments to compare method, because here object is always expand one comparator object. My compiler can able to guess comparator, compare method arguments, right? Now if I1 greater than I2, what I have to return, sir? -1, because bigger value should come before descending order, right? Next, sir, I1 lesser than I2. I1 less than I2, then automatically 1 I have to take, sir. Sir, 0, if it is not satisfied, 0 I have to take. Regarding 0 I have to take, sir. That's all. This total thing itself is nothing but lambda expression. Remember this one itself is lambda expression, right? Sir, if you are writing lambda expression, what is the need of taking my comparator? My comparator, I can able to remove, sir. I can able to remove. I'm not going to use comparator explicitly. That's all. Just this is a small example. We are not required to write big lengthy code. Now observe. Let me execute this code. Perfectly valid. Yes, after sorting 20, 15, 10, 5, 0, customize your descending order is coming. You people may fail. Sorry, showing old output only like this. Let me add one more object. 25, sir. 25. So in our output, 25 also should come or not? Can you please observe? Have a look once. Okay. What is the output by default we are going to get? This is the insertion order, sir. But after customized sorting, descending order 25, 20, 15, 10 and so on. So we can apply lambda expressions concept for collections. Best example to understand this one, right? It's always expecting comparator object. Comparator is the functional interface. Wherever comparator object is required, happily we can replace with the lambda expression. Clear for all of you, right? Can you please tell lambda expressions concept applicable for collections or not? Yes, not only for collections. Everywhere lambda expressions are applicable wherever functional interface is there. Clear, right? That's all, sir. So for array list, by using lambda expression, how you can define customized sorting order? Best example, sir. Yes, you have to code, you have to practice, then you people can able to understand very easily, right? But to understand this, strong knowledge in collections must be required. So before referring there, first you have to go through your normal collections concept. After that, come to this session so that you people can feel more comfortable, right? Okay, that's all. Sir, up to this we covered how you can define customized sorting for array list without lambda expression, with lambda expression, both we covered, right? Sir, that is the list story. Now I want to use set concept, right? In the case of set, if you want a sorting order, then we should go for tree set. Do you know? Tree set is set implementation class. Tree set is set implementation class. This tree set, if you want natural sorting, if you want some sorting order, then we should go for tree set object. Remember that. Sir, if I create tree set object without any argument, sir, best example, assume that I am creating tree set. of integer t is equal to tree set of integer t is equal to new tree set of integer I am taking, sir. Am I passing any argument? No, I am not passing any argument to the constructor. Then this tree set meant for default natural sorting order. Remember this one, default natural sorting order for the integer means for the numbers is ascending order. Are you getting? If you are not passing any comparator object, yeah, the argument, it is always meant for what? Default natural sorting order. Suppose I am taking, I want, sir, just pass some comparator object. Tree set of integer t is equal to new tree set of integer of, if I pass comparator object, then it is meant for customized sorting order. I hope you people can able to understand, right? So without the comparator object, default natural sorting order, with the comparator object, it is always customized sorting order. Clear for all of it? So now without the comparator object, what is the behavior? Default natural sorting order, is it correct or not? Have a look once. I am taking tree set of integer t is equal to new tree set of integer. Okay, sir, 10, 0, 15, 25, 5, 20. I am adding these integer objects. I am trying to print a t, sir. So default natural sorting order for the numbers is ascending order, right? That's why what is the output by default? You are going to get 0, 0, next and after that 5, next 10, next 15, next 20, 25, like this. Ascending order by default you are going to get, sir. If you want, I will show, I will execute and I will confirm, yes, whether we are going to get ascending order or not. Sir, I am not using any comparator, I am not using any lambda expression. Default natural sorting order by default will be there in the case of tree set. Observe that. Have a look once, sir. Here see this one, import java.util.tree set, class test public static, tree set of integer t is equal to new tree set. Sir, here I am not passing any argument. Are you getting? Am I passing any argument, sir? No, I am not passing any argument. T dot head of 10, 0, 15 and so on, SOP of t. Now let me execute this code, sir. Yes, compile is fine. What is the output by default you are going to get, sir? Can you please observe 0, 5, 10, 15, 25. Are you getting? 0, 5, 10, 15, 25 by default you are going to get, sir. Any doubt about this one? Default natural sorting order there. But now my target is, I don't want default natural sorting order. I want customized sorting order. Then we require to pass comparator object. Regarding we require to pass comparator object, you know, right? So now wherever comparator object is required, happily you can take lambda expression. Have you remembered, right? Wherever you can take comparator object, wherever you have to take comparator object, there happily we can take lambda expression, because comparator is the functional interface. Functional interface can be implemented by, okay, lambda expression. Directly I want to go for, sir, which type of sorting you require? Descending order, because default natural sorting order already there. Descending order I want. If you want descending order, sir, bigger value should come before, smaller value should come after, because descending order means, can you please confirm for this? What the descending order? 25, next 20, next 15, next 10, next 5, next 0. Regarding this is the descending order, right? If you want this descending order, then automatically, yes, how you can able to write lambda expressions are very simple. Bigger value should come before, smaller value should come after. Okay, how you can do that? Yes, sir, here I1 comma I2. Assume these are the arguments to comparator compare method. Okay, if I1 greater than I2, if I1 greater than I2, sir, bigger value should come before. That's why before means -1. Okay, before means -1. question mark minus 1. If this condition not satisfied means if this condition not satisfied means I1 is not bigger than I2, sir. Then again I1 is less than I2. I'm checking, sir. If I1 first object is smaller than second object, smaller value should come after. That's why plus 1. Sir, else, sir, this condition also not satisfied mean I1 and I2 both are equal. Duplicate, can you please return 0? Are you getting? This is the lambda expression for comparator compare method implementation, right? Remember that if you pass this one, the argument to tree set constructor, then sir, according to this lambda expression, by default the elements will be inserted. Obviously we are going to get descending order. Everyone can able to understand, right? How you can write this one? In the last videos with respect to list concept, I explained very clearly about this terminology, sir. Clear, right? Okay, let me use this. Observe that. Observe a bit very carefully, sir. Here within bracket, or otherwise let me write separately so that you people can feel more comfortable. Sir, I1 comma I2, sir. I1 comma I2. Okay, so these are the arguments to compare method of comparator. Okay, I1 greater than I2. If I1 greater than I2, bigger value should come before only. That's why minus 1. Next I1 less than I2. Sir, if I1 less than I2, then sir, I1 is the smaller value should come after. That's why plus 1. Next and after that, sir, here do you know plus 1? Next and after that, sir, it is not I1 greater than I2, it is not I1 less than I2, then automatically return 0. Are getting return 0. This is the lambda expression that implements comparator according to descending sorting order. Now let me pass this one. Let me pass this one as the argument. Have you observed, right? Within just a constructor, I'm passing this one as the argument. Now have a look once. What is the output by default we are going to get, sir? Perfectly itself is valid. The output by default we are going to get, yes, have you observed? 25, 20, 15 and so on. Earlier, what the output descending order, but now we are going to get descending order, right? Sir, it is very clear for you people, lambda expressions concept can be used for a tree set if you want to define customized sorting order like a descending order. Clear? Any explanation is required? Just the previous example list, whatever comparator we took, whatever lambda expression is the same thing only. Okay, that's all, sir. Sir, up to this we covered how you can apply, sir, customized sorting for the tree set with the lambda expressions, right? Okay, now why don't you apply lambda expressions concept for the map also? Same lambda expression, how you can able to define customized sorting for the tree map? Observe that. Sir, in the case of map, if you want customized sorting, if you want sorting, then our hand should go for tree map concept. Remember this one. Our hand should go for tree map concept, right? Tree map always meant for sorting order. Key value pairs will be inserted according to sorting order of keys. Remember this one. Sorting is always based on the key, but not based on the value by default. Okay, now my question is how to create tree map object. Observe that carefully, sir. Here I'm taking tree map of here integer comma string. Tree map of integer comma string. T is equal to new tree map of integer comma string, sir. Integer comma string, like this I'm taking. Here observe, this tree map can hold the key values where key is what type? Integer type. Value is what type? String type. Remember this one. By default, tree map is always meant for default natural sorting order of keys, because here we are not passing any comparator object as the argument. If you are not passing comparator object as the argument, then default natural sorting order by default will be there. Sir, default natural sorting order for integer means what? Alphabetical order. I hope you aware. Integer means ascending order, right? Now let me consider tree map of integer comma string m is equal to integer comma string, tree map of integer comma string. Sir, I am not passing any argument. If you are not passing any argument, default natural sorting order for the integers keys is nothing but ascending order, right? Now 100 Durga, 100 is the key, Durga is the value. 600 Sunny, 300 Bunny, 200 Chinny. Like this I have, sir. Okay, like, can you please tell SOP of M? What is the answer, sir? Curly brace open. Ascending order of keys 100, 600, 300, 200, 700, 400. 100 is going to come. 100 is equal to Durga. First one, sir. 100 is equal to Durga. Next one, 200 is equal to Chinny. 200 is equal to Chinny. Next, 300 is equal to Bunny. 300 is equal to Bunny, like. Next, 400 is equal to Pinny. 400 is equal to Pinny, like this. Next, sir, have you observed? Is there anywhere 400 completed? 600, 700. 600 is Sunny. Are you getting? 600 is the Sunny. Last one, 700 is nothing but Winnie. By default, we are going to get. Are you getting? Sir, according to ascending order of the keys, by default we are going to get, sir. Observe that according to ascending order of keys, by default we are going to get. Is it clear for all of you, right? Okay. Sir, now I don't want this default natural sorting order. I want a customized sorting order. How you can define with lambda expression? Same concept. Whatever we applied for array list, whatever we applied for the tree set, same concept we can apply for the tree map also. That part I will discuss. Let me execute up to this, right? Observe that a bit carefully, sir. Here, tree map of integer string m is equal to new tree map of integer comma string m dot put a 100 Durga, 600 Sunny, 300 Bunny, 200 Chinny, something like this, right? SOP of m. Are you getting SOP of m like this, right? Now let me compile. Let me run. Have you observed, right? What is the output by default? We are going to get, sir, 100 Durga, 200 Chinny, 300 Bunny. Like this by default we are going to get, sir. According to ascending order of keys. Observe 100, 200, 300, 400, sir, next 600, next 700, like. According to ascending order of keys, by default will be there. Everyone can able to understand, right? Sir, I don't want default natural sorting order. I want customized sorting order. How you can, sir? I want a descending order of keys. How you can? Just here to the constructor, you require to pass comparator object. Are you getting? We require to pass which object, sir? Comparator object. Sir, wherever comparator is there, happily we can use lambda expression, because comparator is the functional interface. I covered already, right? Yes. Can you please tell what is the way, sir? I1 comma I2. Assume that these are the keys, these are the arguments to compare method. Okay, sir, like. Now, if I1 greater than I2, sir, question mark, sir, bigger value should come before, that's why -1 colon. If this is not greater, then automatically I1 less than I2. If I1 less than I2, this is the smaller value should come after, that's why. So after means 1 positive number, otherwise 0. Sir, The same lambda expression we are using multiple times. Are you getting? We are not required to use class, my comparator, implements and so on. Instead of that thing, directly you can use the lambda expression, right? Observe that carefully, sir. Can you please guide? What is the lambda expression I have to take here? Please guide. Please guide. I1 comma I2. These are the arguments to compare method. Internally I1 and I2 are keys, right? Now, what is the first one I have to take? If I1 greater than I2, which value I have to return, sir? Minus, because bigger value should come at the beginning only. Next, I1 less than I2. If I1 less than I2, sir, I have to take plus 1. Otherwise, I have to return 0. Are you getting? So, if it is the bigger, I1 is the bigger than I2, bigger value should come first, that's why minus 1. Sir, else if I1 is the smaller than I2, then automatically smaller value should come before, smaller value should come after, that's why 1. Sir, it is not greater, it is not smaller, means equal. Equal means return 0, automatically treated as duplicate, sir. Now, have a look once, let me pass here. Let me pass this one. If I pass lambda expression, yeah, the constructor argument, what is the output by default we are going to get, sir? Observe that carefully. Yes, 700, 700, 600, 400, 300, 200, 100 by default. So, earlier we are getting ascending order of keys, but now we are getting descending order of keys. That's why, sir, how cute it is. Just we have to write how much lines of the code? Just only one line. We are not required to write separate class, my comparator and so on. Are you getting right? So, lambda expressions concept applicable for the tree map or not? Why, man? Why not? Happily it's going to be applicable, no problem at all. If you feel comfortable up to this, I hope. Yes. Are you feeling comfortable? But anyway, you should have clear collections knowledge must be required. Then only you can able to understand, right? Okay. Don't worry about that. Just once you start coding, then you can able to get much clarity, right? Okay. If you feel comfortable, then how you can apply this lambda expression sorting technique for our employee objects, for our own customized objects, how you can able to apply that part I will discuss, right? Okay. That's all. Now I will explain how to define customized sorting for our own class objects like employee object, student object, customer objects like. Sir, here I don't want to use comparator implementation class. I want to use lambda expressions only. How you can able to do? Suppose if you consider employee. For every employee number will be there or employee name will be there. Regarding employee number or employee name. I want all employee objects. Can you please insert according to ascending order of employee number or according to descending order of employee number or according to ascending order of salaries, descending order of salaries or according to alphabetical order of names, something like we can able to define customized sorting for our own class objects also. How you can able to do that, sir? Very, very important concept. Take special care about this one. Observe that. I want to take my own employee class employee. I am taking my own employee class. This employee class contain, sir, two properties. Int employee number and string employee name. Observe that carefully, sir. Int employee number, string employee name. Okay. Now I am taking, sir, constructor employee of int enum comma string ename employee name, sir. String ename like this or just a name you can take. Now this dot number enum is equal to enum. This dot ename is equal to ename like this I am taking, sir. This is the employee. Sir, constructor, whenever you are creating an object to perform initialization, this constructor is going to execute. Whenever we are printing employee object, meaningful representation purpose, meaningful string representation purpose, let me override toString method. Are you getting? Which method I am overriding? Let me override toString method, right? toString, when it is going to come, I will show. Return, if any person trying to print employee object, sir, how it is going to print? Return enum plus colon, enum colon, ename, like this, meaningful string representation. I am overriding toString method. If you are going to print employee object, then toString method is going to come in the picture. Best example, employee E1 is equal to new employee. Employee E1 is equal to new employee. 100 comma Durga I am taking. Assume that, sir, 100 comma Durga. Employee number, employee name. Let me print this E1. Let me print this E1. Internally, toString method will execute. toString method is going to return 100 employee number colon name Durga. Are you getting it? Name colon 100 employee number colon name. This is the output by default we are going to get, sir. I hope everyone in a position to understand what is the need of this toString method. Just let me show, and then we can think about customized sorting, sir. Have a look once. Sir, class employee, int enum, string ename I am taking, employee, this dot enum like this. Sir, like even I override toString method also, right? Now, let me create one employee object. Here, employee, sorry. Here, employee, sir, E1 is equal to new employee I am taking, sir. Is 100 is the employee number, Durga is the employee name. Now, print, sir, here system.out.println of E1 I am taking. SOP of E1 I am taking, sir. Now, observe that whenever we are trying to print E1, internally employee class toString method is going to call, which is going to print enum colon ename. Observe that. Observe carefully, sir. What is the output by default we are going to get? Observe 100 colon Durga. That is the purpose of overriding toString method. Suppose I didn't override toString method. No meaningful string representation, sir. If you want to observe, what is the output by default you are going to get? Employee at the rate. If you don't want this type of output, then happily we can go for toString method overriding. That's all. First level, what the need of toString method, clear. Okay. Now, sir, let me go for, I'm taking array list of employee. L is equal to new array list of employee. Array list of employee L is equal to array list. Sir, I am creating array list object to hold employee objects. Okay. Now L dot add of new employee 200 Deepika. 200 is the employee number, Deepika is the employee name. Similarly, new employee 400 comma Sunny. Next 300 Mallika. 100 Katirna. Like how many employee objects I am adding, sir? 4 employee objects I am adding, sir. Sir, 200 Deepika, Sunny, Mallika, Katirna, like. Sir, what is the output we are going to get? Very simple, sir. Very simple, insertion order. Because it is the array list, right? Insertion order by default will be preserved. What is the output, sir? Sir, 200 colon Deepika. First employee object. Because of toString method, it is going to come. Second one, sir, 400 colon Sunny. Okay, like 400 colon Sunny. Next objects are 300 colon Mallika. Like this we are getting. Next 100 colon Katirna. Like by default we are going to get this output, sir. Now my target is, I want customized sorting order. Can you please insert all these employees according to ascending order of employee number, ascending order of employee number I want. How you can able to do that? Very simple, sir. Here collections dot sort of L. I'm always expecting comparator. Comparator object as the second argument, right? But wherever comparator is required, happily we can replace with the lambda expression, right? Now, sir, which objects, employee objects are arguments? Okay, E1 comma E2. Sir, if two employees are coming, I have to compare based on employee numbers. That's why E1 dot enum, E1 dot enum. 1 minute, sir. 1 minute. You may get confusion. Here, see. Sir, first employee, comma, second employee. Let me write separately lambda expression so that you can feel more comfortable. Sir, first employee number is lesser than second employee number. Have you observed, right? First employee number is lesser than second employee number. Then smaller employee should come before. That's why question mark -1. Can you please, if this condition satisfied, return -1. Else, sir, first employee number greater than second employee number. Oh, sir, this condition not satisfied. First employee number is greater than second employee number. Greater employee should come after. That's why, sir, question mark 1 positive number. Sir, this condition not satisfied. This condition also not satisfied. Then automatically 0. Are you getting? 0, both are equal. If you pass this lambda expression as argument to this sort method, automatically all employees will be sorted according to ascending order of employee numbers. Sir, wherever comparator is required, happily we are allowed to use what? This lambda expression. Clear for all of you, right? So lambda expressions concept applicable for, okay, this for our own objects for customized sorting, sir. Okay, let me show. Have a look once. 1 minute, sir. I saved already this code for your sake. Observe carefully, sir. This is important one like this. Sir, now the same objects, right? Collections dot sort. Have you observed? I don't want to take like this. Yeah, I want to repeat again. Can you please observe? E1 comma E2. E1 comma E2. Sir, if E1 dot enum less than E1 dot E2 dot enum. E2 dot enum. Sir, have you observed? First employee number is smaller than second employee number. Then first employee should come before -1 colon. Again. Sir, first employee number, if it is greater than E2 dot enum, then, sir, first employee number greater means after means +1. Okay, or, sir, this condition is not satisfied. This condition is not satisfied. Automatically 0. Sir. Sir, use this lambda expression as argument to collections dot sort of L comma like this. Are you getting? Sort of L comma like this. Now observe that. So before sorting, what is the L? After calling sort method, what is the L? Observe that. Observe the outputs are here. Yes, the code compiles fine. Now before sorting, are you getting insertion order? 200, 400, 300, 100 like this. But after sorting, 100, 200, 300, 400. Ascending order of employee numbers. Based on ascending order of employee numbers, by default sorting happen. Okay, clear, right? Sir, these are various things what you people should be aware about the lambda expressions for collections concept. Sir, whenever we published this course, majority of the people are telling, sir, lambda expressions for collections how to use. Can you please explain with multiple examples like? But make sure to understand this section, compulsory you people should have strong idea in collections. First, go through the collections concept, and after that, just just review all these videos so that you people can get much clarity. Clear for all of you, right? Sir, now lambda expressions concept applicable for multi-threading or not? Yes, runnable interface implementation, we replace it with lambda expression. Next, similarly, comparator internal implementation replace it with lambda expression. Very concise code. One small expression replaces a big class, sir. That is the biggest advantage of lambda expressions concept. Sir, very simple. Whether it is the multi-threading, whether it is the collection, wherever functional interface is there, happily we can replace that requirement with the lambda expressions. Clear up to this? That's all. Thank you, sir.